What is a design engineer? Isn't known the technology enough? In this episode, I'll explain what it takes to become a good design engineer and the approach we follow. If you're looking to move up to the next level, keep listening.
Do you want a career in networking but aren't sure where to start? Are you struggling to take your career to the next level but aren't sure the path? Welcome to Cyber Job Hacks, the podcast that gives you the strategies you need to launch and grow a successful career in network engineering. Hosted by Dr. Jeff Colburn, a solutions architect with over 30 years of experience designing and implementing large-scale networks. Each episode is built around one of the three core pillars of becoming a next-level engineer: developing deep technical knowledge, applying design best practices, and understanding technology decisions. Let's get started.
Want to know more on what it takes to become a top network engineer? Be sure to download the 3 Pillars of Network Engineering. This guide will provide you a framework to move your career to the next level. You may find it at colburncareer.com or click the link in the show notes. Welcome to the Cyber Job Hacks podcast. I'm your host, Jeff Colburn. On this episode, we're going to continue with the 3 pillars of network engineering. Last episode, we discussed how to develop a deep technical expertise. However, knowing that technology is not enough to become that next level engineer, which brings us to the second pillar, design best practices. You have to know the technology, but you also have to know how to design with it, because you can't design with what you don't know. And believe me, it's evident in some of the networks I've seen. You really have to, you have to know the technology, and then once you know that technology, then how do I design with that technology? So this second pillar, this is what moves engineers from being ops engineers to design engineers. Now, good ops engineers, they know their technology and they really know how to troubleshoot it. But that doesn't make them a good design engineer. So a next level engineer is always looking to elevate themselves to a level of network architect. It's part process and it's part art, right? You know the technologies, you know how to design with it, you know best practices, you have a design methodology or design approach that you follow, but also takes some creativity, that there's some art to network design. And you develop that over time, just kind of like a painter. You know, the first time somebody paints, it's not a masterpiece. It might be a little clumsy, but over time, they develop their own approach, their own methodology, and their own style. So that's the same with network design. You could develop your own style, your own approach to how you design networks. But of course, whenever you design a network, you always have to start off with the requirements. You don't start building a network until you have the requirements. Right? And so you have to capture these requirements. You got to understand these requirements, and there's business and technical requirements that have to be captured. You want to eliminate as many design assumptions as you can. If you can have no design assumption, that's perfect. But it's rare. You always have some sort of design assumptions. However, you try to eliminate as many as that as possible. So how do you capture requirements? Well, the way I like to do it is stakeholder interviews. I ask the customer. I don't want to assume to know what they need. I want them to tell me. And if they're having trouble articulating what their requirements are, then I'm going to work with them because I want to help them nail down the requirements. What do they really need? What must they have? What has to be in a network? What can't be in a network? And you can use something like Moscow, right? So Moscow is, must have, should have, could have, and won't have. This is kind of an acronym to kind of prioritize your requirements, right? The must have are these things that have to be included in the design. Just can't be missing, right? And this should have is like, it doesn't have to be there, but it'd be nice if it was. We would prefer if it was, right? Then there's could have means if it's there, great. If it's not a showstopper, right? It could be there, but it doesn't have to be there. And then it won't have is like, this is not going to be included in the design, right? So you're going to document all this, right? You're going to document the customer's requirements. technical and business requirements, and you're going to prioritize it. And you're going to prioritize it by, you see the spectrum from must have to won't have. So that's going to tell you all the must haves are going to be top priorities because they have to be included. So when you are conducting these stakeholder interviews, don't forget the security and compliance people. They're going to have a lot to say about what must be in design and what must not be in design. So you definitely need to talk to security and compliance because they're going to have a lot of influence over your design. Excuse me. So chances are that this is not going to be a greenfield network, and you're going to be either adding or modifying to existing environment or what we call brownfield. So you're still in this discovery phase, right? You're gathering the requirements, you're capturing requirements, but you also have to gain an understanding of the current network environment, right? So it's like they already have a network in place and you might be modernizing it. You might be adding something to it. You might be replacing a technology. And a lot of times, customers going to give you diagrams. Don't trust them, right? They're usually outdated. They might have things that were added or removed still on the diagram. If you follow the diagrams as the snapshot of the current network, you're probably going to get burned by it. So the best thing I always ask for is if I can at least get read access to the network. So I can go in there and I can start exploring, get a feel for the network, see how things are configured, look at their routing protocols, and you're going to find all kind of what's wrong in that network. I mean, some things that people are doing is, believe me, it's not in the diagram. You have to get in there and you find it. And if you don't find this and you try migrating, it's these kind of things that are going to break what you're trying to do. So that's why you want to get in there. And there's things people try to hide. They did something to get something to work, but it may not necessarily be a good thing that they did, so they try to hide it. Believe me, I encountered this many times. So you want to get in there and take a look at the network. And the best way is if they allow you to get read access and go in there and look yourself. Sometimes you have to do over the shoulder. I've had that too, where they wouldn't grant me my own access. So I had to work with one of their engineers and I just tell them what commands to execute so I could take a look at things. Done that too, but at least it gave me eyes on their network. So this is that critical information that so when you're developing your design and migration plan, this is the information, right? The requirements in current network state, right? We call current state, right? Because you can be designing to end state, but you begin at current state, and that's what you're trying to get the best understanding of. So now that you have that, now you start exploring design options, right? You start moving into that high level design phase. You want to, you start seeing, what's possible based upon the requirements, based upon what they have today. And a lot of times I want to explore these options with a customer. I want to hear their thoughts. They might have some ideas on what they think they want to move to. So I'll hold whiteboard sessions. I'll collaborate with their engineers, because their engineers, they know the network better than anybody. So I want to include them, so I collaborate with them. So you want them working with you throughout the process. If you want to build resentment and quickly experience a lack of cooperation, go ahead and exclude these engineers, because already there's some level of resentment because they've been working on this network for years, and then you come in and all of a sudden you start telling them what they need to do to the network. It's almost like they feel like you're taking their job, or just taking away something that they feel like they can do themselves. So if you include them in the process, collaborate with them, hear their ideas, share your ideas with them, it's a much more pleasant working experience. So you include the engineers because they are a great wealth of information about the current state of the network. And so this is what you do. You're building this high-level design, this conceptual design. And at this point, you're not even thinking about vendor or platform. This is purely thinking what technology or technologies best meet their requirements. Do best practices apply here? Or do the requirements call for something else? What technologies have others used for similar requirements? How did they implement that technology, right? It's rare that you're going to be the first one to encounter a new requirements. Usually it's been done before and you can reference what somebody else has done. But sometimes you have to get creative. In the past, I've kind of come across something that was brand new or was a unique requirement. So I had to come up with a design which hadn't been done before. Actually, one of my designs, my customer actually received a patent because I gave them a competitive advantage for what they were trying to do. So, there's times you got to be creative, but other times somebody's already done it in the past and done it several times and is the best way of doing it. And if it meets the requirements, then you don't go try reinventing the wheel. You just like, hey, this is how you implement this technology. But as you're doing this, you have to maintain this holistic view of the network. You can't get siloed and just working on that area of the network that they might have brought you in for, because you have to see what you're doing doesn't impact the rest of your network. So even if you might just be working on a portion of the network, you still have to take a holistic view of the network because you're trying to make the network as efficient as possible. And you don't want something that you're putting in to create inefficiency throughout the network. Right? So you got to be mindful, have that holistic view, which is rare because I see so many people, they just get laser focused on what they're working on and they try bolting this thing into the existing network and it breaks things. So be mindful. That's a good design engineer. They take the whole picture in mind. So that's what we call high level. Diagrams have very little detail. It's mostly conceptual. The goal is for the hardware to match design, not the design to match the hardware. So you're not thinking, I'm going to buy this equipment, I'm going to buy this technology, and then I'm going to make the design work. No, it's come up with that high level design, that conceptual design, very little detail, and then you're going to get into platform vendor technologies. So this is not a time to pick what's popular in industry. It's not what the vendor suggesting you move to. It's about what best meets the requirements. And you don't want to over-engineer, and you don't want to add unnecessary complexity. You're right, because at the end of the day, somebody has to operate this network. So, do them a favor. Don't go crazy. I believe it was Russ White who said, make the network as complicated as it needs to be. So don't overcomplicate it. But, some people say keep it simple, the KISS philosophy, which is great. But sometimes you have to add some complexity to meet the requirements. So you just make it as complicated as it needs to be. Don't make it overly complicated. You're certainly not trying to turn it into one of these labs that you use to learn the various technologies. You're trying to meet requirements, both business and technical, and what technology best meets those requirements. So when you're developing this high-level design, right, you got to think in terms of, what's best for the control plane technology, what's best for the data plane technology, and how the network's going to be managed, right? So you're thinking these things separately, right? I have a control plane. What's my routing protocol? Like, what's my data plane technology, right? And then how's it going to be managed? Is it in band? Is it out of band, right? So these are all things that you're thinking about. And then modularity, right? How can I design this network so it's modular? So if I scale, right, it's gonna scale. I can add to it much easier, right? And then I want to think about resiliency, right? How can this network survive failures and protect its critical applications, right? And then what are the data flows, right? And, that person-to-person traffic, person-to-machine traffic, machine-to-machine traffic. You kind of want to map that out and understand how those data flows go through the network, right? Because that's going to, again, impact your design, that high-level design. And then what security measures have to be included? There's no better way to break your design than having security bolted on after the fact. So you're going to want to include security as part of that design mindset because you need those elements incorporated into your design because you're either going to have to scrap your design or it's going to be less efficient because you didn't have the foresight to include those security measures. So, all right. But once you have that high level design, customer agrees, yep, that's the design, that's the technologies we want to use. Now you go into something we call like vendor selection. You start looking at specific vendors and platforms that meet your design requirements. And this is when you meet with the vendors, you're testing the hardware. You might have a proof of concept so the vendor can prove that their hardware does what it says it does, right? You don't want any surprises when you implement this stuff in a production environment. So you want to do as much testing ahead of time, even if it's just like getting some equipment in your lab and testing functionality, because you more than likely you are going to have some surprises during migration, but you want to reduce as many surprises as possible. And certainly one of those surprises you don't want is you bought hardware that doesn't do what they claim it does, because there's no fix for that. So you want to test that beforehand. And this is what we call vendor down select. We start going from several vendors to reducing it down to a handful of potential vendors. And then typically what I do is I present options to the customer. I say, okay, here's the vendors, the technologies, here's the strengths and weaknesses of each. And they ultimately select the vendor. And it may, when they actually do make the selection, it may not be the one you've picked or you think best meets the design requirements, because usually price and politics play a role. So you might find yourself working on vendor equipment that you don't believe was the best choice, but that's out of your hands, right? The customer selected them. So now you have to adjust. I've seen times when because of price, they even went with equipment that fell short of the requirements that they articulated. So I had to adjust the design. But these are things. This is what makes you a good design engineer, is when these things come at you, you know how to adjust. You anticipate, well, what if they pick this person? Well, what's the design going to look like, right? So that's what makes a good design engineer, that, that flexibility, that ability to adjust. Because even when you get into migration, you might find things that weren't discovered previously, and you're going to have to adjust. So there's always adjustment. And sometimes your end state design at the end may not look completely like the original end state design at the beginning, right? Because certain things came up, politics, the vendors that were selected, or even things that appeared in migration phase. So just be prepared to be flexible. But once you have that, once you have the high level design, you have the vendor, the platform, the technologies, then you start getting to that low level design. This is where you start adding the details. This is that end state design. This includes the vendor, the model. This is the IP addressing, the ports. This document, this low level design, you could hand to somebody, and they could build the network from without any other information, because it's all contained in that low level design. We call the detailed design sometimes, but it's a low level. It's very specific, has all the information you need. So that's what you develop. But now you have this low level design. But that low level design does not match current state. So that end state and current state, you have to get there. You have to get from current state to end state. So that's where we talk about migration. And it's very rare that you're able to move from current state to end state in a single change. I've yet to see it. There's usually a period of migration. It's like, how do I move from the old to the new technology without breaking anything? How can they coexist? I still have part of the network on the old and part of the network on the new. They still need to communicate. So what's that transition network look like, right? So that's what you do when you come up with that migration plan. And that's what you execute upon, right? It's migration plan, implementation plan. It's a detailed steps that need to be followed to get from the old to the new, right? But then, once it's migrated, or even during migration, you probably execute some levels of acceptance testing, right? During the design phase, you'll develop something called the acceptance test plan. It's going to contain a series of tests that verify different functionality to ensure that your design meets the requirements. So that's the acceptance test plan, and you're going to execute that, and then the customer is going to sign off on it. And then once you're fully migrated to the end state, and you have an executed acceptance test plan, and everything passed, your job is done. You went from requirements gathering to high-level design, vendor down select, low-level design, migration, and then acceptance test. That's the life of a design engineer. And that's where that art comes into. Like when you're developing these designs, when you're selecting the technology, you know the technology, you know how to design with it. You know industry best practices. You know when they fit, when they don't fit, when you have to get a little bit more creative, right? These are all the things that makes a great design engineer. So, that's that second pillar. So you have that deep technical expertise, or the deep technical knowledge, And now you have design best practices, and you have a design approach or a design methodology, right? Which is, again, you're completing that second pillar, right? Which is ultimately going to lead to that third pillar, that technology selection rationale. Because as you're picking technologies, as you get better, you're going to be able to rationalize why you selected this technology over another one. But when you first start designing, you may not be there yet. It's going to come in time. You may just this looks like a good place for VXLAN. And you may not know exactly why it's the choice. It's just, that technology will work, but you can't articulate that, that reasoning behind it. And that's going to come. That falls shortly behind pillar 2. Like pillar 1 to pillar 2, it might take longer, right? Because you're learning the technology, and then you have to learn how to design with it. And when you start designing more and more, that third pillar develops quickly, because customers are going to ask you, well, why did you pick this technology? And you're going to have to give an answer. You can't just say, because. You explain why this technology is the better choice over some other technology. So I just want to thank you all for listening today. I hope as you're going on this journey, as you're growing and trying to become that next level engineer, I hope you find this helpful. Until next time, hit the books.
Thank you for listening to Cyber Job Hacks, the podcast for next level engineers. If you found this episode helpful, be sure to follow the podcast so you don't miss future episodes on how to take your career to that next level.